In this tutorial, we will take a look at chirp synthesizer, then combine it with a residual synthesizer to generate some bullet whiz sound effects. Our final result should sound something like this. You can view this graph in Meta Sound Preset Range Weapons folder. Now let's start with something simple. If you open UI folder, you will see 3 graphs for beep sounds. Each graph uses a different synthesizer to generate a single beep sound. The first graph uses a chirp synthesizer node. The setup is very simple, and this graph is like the best way to create a simple UI beep. It's much faster and more flexible than playing a WAV file. Note that you can turn a chirp synthesizer into a modal synthesizer by changing its chirp rate to 0. In the document, you can view the equation for modal synthesizers in section 1.21. For UI sounds, we want to directly control our desired frequency, so modal parameters pin isn't used here. When you use F0, the default value for amplitude and decay rate is 1. By changing decay scale, you can control the duration. And you can use chirp rate to add more nuances. A small value should be enough. But let's use a big value here and view the output to better understand what this does. I will add a wave writer node. Render the output. And I will view this on Sonic Visualizer. We need to view its spectrogram. As you can see, my initial frequency is the same as specified in F0, and it increases linearly over time. The chirp rate determines how fast my frequency will change. Currently, my chirp mode is linear, so with a positive chirp rate, the frequency keeps increasing linearly. Let's try a different chirp mode. You will need to promote this to graph input. You can see that we have 3 chirp modes. I will use exponent mode for now. For linear mode, you can leave chirp duration at -1. But for other modes, we need a positive value. I will change this to 0.5 and chirp rate to 1. Render it again. And view it on Sonic Visualizer. You can see that the frequency starts at a very small value. Then it increases non-linearly to F0. This increasing duration depends on both chirp rate and chirp duration. Sigmoid mode is very similar to exponent mode, but it has an overshooting effect. We will learn more about these 2 modes, the random rate and the amplitude random range, in an engine sound tutorial in the future. Let's get back to Unreal Editor and create a new Meta Sounds graph for bullet whiz effects. By default, the output is mono. I will change it to stereo. We need a whoosh sound effect first, so I add a residual synthesizer node. Connect all the default input and output pins. Promote residual data to graph input and choose whoosh bullet. If you open this residual data, you'll see how it's created. This has already been explained in Generating Whoosh tutorial. You can change shift energy by frequency a little bit for more variations. I will copy the preview values to my synthesizer. Sound like a whoosh, but the wind up is a little bit long. I will change start time to -0.5. This sounds faster now. But we need to make it more interesting. A whoosh has two parts, winding up and winding down, or coming close and passing by, respectively. So I will use a chirp synthesizer to enhance them. Let's add a chirp synth node. Use a stereo mixer to mix the outputs. And combine on finish trigger. For bullet whiz, I'll change F0 to 1100 Hz. I want the first part to have a negative chirp rate and the second part to have a positive chirp rate. This is kind of wrong compared to the Doppler effect. But it's okay, since bullet whiz effects aren't really realistic anyway. To change the chirp rate, I will first add a trigger delay node. We don't need the delay time to perfectly match the start time of the residual synthesizer. I think 0.1 second is fine. This will trigger when we need to change the chirp rate, so connect it to a trigger route node. The first part will have a chirp rate of -2000, and the second part is 60. Try playing it. Lasts way too long. To reduce its duration, I will change the decay scale of the second part to 20. Whoosh is the main layer, so I increase its amplitude to 2. The chirp synthesizer output is still too loud. I change its amplitude to 0.1. Currently, we only have one frequency. I'll add a harmonic frequency to make it sound more natural. Copy this node. Promote F0 to graph input. Divide it by 2 and connect all the pins. Let's share the amplitude scale too. A harmonic frequency should have a lower energy than the base frequency, so I reduce the amplitude of the second node by 20%. And increase the decay scale by 0.2. I'll use a mono mixer node to combine their output. With a harmonic frequency. And with only the base frequency. Sound fine, but I want to have more variations. So I add a random node to randomize play speed and start time. I want both of them to vary by 30%. So the minimum value is 0.85, and the maximum value is 1.15. Then I multiply the output with the start time and play speed. I will do the same for F0. And with just that, we already have some very noticeable variations. Of course, you can still add more randomness to the decay scale, amplitude scale, chirp rate, and delay time. Or use a trigger filter like this to make even more unique variations. And that is the advantage of a fully procedural graph. You can easily modify anything at any time. Let's view the spectrogram of the synthesized sound. You can see that 2 frequencies went down in the first part. The chirp rate of the second part is a bit small and the duration is short. So they look like 2 straight lines here, but they're actually going up. If you look into Range Weapons folder, you will find a graph named Whiz Disrupt. This graph is very similar to our graph, but the trigger route on set is connected to play trigger instead of the random node. Basically, this resets the frequencies of the second part to F0. Notice how the second part has higher frequencies now. Let's view its output in Sonic Visualizer. You can see the disruption right here. It makes the second part even more noticeable. Some might like it, some don't. So it's up to you to decide what to use. I hope you find this tutorial helpful, and I'll see you again on the next one.